Here we are. Let's do preorder traversal. And just like I'm going to use Java 8 and let's go. So what we have to do is we're going to traverse. Remember, use recursion, which the function name here is preorder. So you just call itself. So first you got to think about what is the base case when the given input, which is called root here, that is null. Okay. We're going to just return, not do anything and see it's void. Else, if there's a node to process, we're gonna process it. In this case, they want us to print the values. We're gonna do system dot out dot print the value itself, which is root dot data, and then we're gonna add a space with concatenation, so that the next one has a space in between. And that's the processing part. Remember, when we do preorder, we do the processing first. After that, we do the recursive call on the left and then on the right if they exist. So if root dot left, if there is something that exists, is not null, right? We're gonna traverse or preorder, which is the name of the function here, the root dot left node. And then after that, if in the same manner, if root dot right does exist, we're gonna do a traversal on root dot right. And that is it. That should do it. As you can see, your output here, my output is 1 space, 2 space, 5 space, 3 space, 4 space, 6, and there's a space here, but it doesn't really matter, but the expected. So it matches. See all the test cases. Like I told you before, the way you visualize is you start drawing a line here in the sample input. Start drawing a line starting from the left. And as you reach the nodes from the left, you're going to process or print their value. In this case, the node, if you look to its left, it has kind of touched or looked at the line that or the curve that you're drawing. Therefore, I'm going to print 1. And then, okay, I've touched 2 from the left, I'm going to print 2. I've touched 5 from the left, going to print 5. I'm going to touch 3 from the left, going to print 3. I've touched 4 from the left, going to print 4. And then I can go up here like surrounding it. And I see that I touch 6 from the left, I'm going to print it. And that's it. Go all the way up back to the root. Now, as you can see this, it tells you about how to visualize the order of preorder. Now, as you're going to see later, we can do the same thing for Inorder and Postorder. Inorder be when you kind of touch it from the bottom, from down, and Postorder be when you touch it from the right-hand side. Okay. Let's look at the next one. Okay, now let's talk about in Inorder traversal. Now, we learned preorder. If you learn preorder, you already know how to do in and post. There will be only one thing that will be different, as we're going to see in a bit. So let's make a dummy tree. I'll make a node with value 1. I'll make a left child with value 2. I'll make a right child with value 3. Then I'm going down to node with the value 2, make a left child with value 4. I'll make a right child with value 5. Now, what we're going to do here is, whereas preorder, we first look at the current node and then process it, for example, print its value. Inorder is going to be first looking at, instead of looking right away at the node that is present, we're going to first look at the left child. Then after looking at the left child is when we look at the current node. And then after that, we're going to look at the right. Let's get started here. So if I make a function called traverse with some node or current node or whatever you want to call it, you're going to look at processing the current node only after you traverse its left child. And then after you process is when you traverse the right child. So the only thing different here from preorder is the order of the statements. What I did for Inorder is I moved the processing to after the first traverse instead of doing it before. If you recall from the previous one, preorder, I did the process here before traverse left. So let's go back. So we're going to have to deal with the base case. So if the current is null, we are done. We don't have to do anything. We just return. We don't have to do the traverse process traverse. That's the base case. Otherwise, how are we going to end this? We have no way. Okay. So let's try it out. If I start off with traverse call to the root, remember the root is the very first node at the top. So we gotta check, is this node which I call occur? Is it no? It is not no, therefore this is skipped. We go to the next statement. Then we're gonna do traverse of the left child, if there is a left, right? You gotta make sure there if left, if L, I'm gonna make it short, and if right for the other one. Oops. Remove it. If right to the other one. Okay, so we're gonna traverse with 2. Now make a recursive call. And then we are 2. We go back to the top. Is the node with the value 2? No. It is not null, therefore skip. Go to the next statement. Traverse its left child, which will be 4. So that's what we're gonna do. Go back to the top. Is the node of 4? No, it's not null, therefore I'm gonna traverse its left child. However, there's no left child. That's why I put a if here. If there's no left child, I don't do anything. I skip the if statement. I skip that traverse. After that, we're going to process the current, which means in this case, we're just going to print. So we're going to print 4. After that, we're going to traverse its right child. There's no right child for the node with value 4. Therefore, do nothing. We're done with that recursive call. We go back to the node 2, and now we can finally process it, which is the next line. And that would be 2. And then finally, we can traverse its right child. And then because we're doing in order, we first have to look at the left in order to look at itself. So there's nothing in the left. We skip that. That can finally process itself. It's 5. We look at the right. There's nothing on the right. Skip that. Now we're done with this recursive call. Go back to the one for 2. We are done with the current, traverse the current right. Then we go back to the node 1. Finally, we can print 1 because that's the second line. Remember, we're still in the traverse left for the node of value 1. That's why we're still there in the recursive call stack. Now we're here, right? We're going to process and we print 1. Finally, we're going to do the right hand child, which is 3. Then we have to first do what? We do the check, and then after that, check the left. Is there left? If so, traverse. There isn't any, so I skip. Finally, we do the process, print the 3. Then after that, we're going to do the right child if there is a right child for the node 3. There isn't any. So we finish that, finish the recursive call, go back to the node 1. We don't have anything else left to do, and we finish it. Then we get 4, 2, 5, 1, 3 for Inorder traversal. And you can compare that with the pre, which is quite different. For the pre, we did 1, 2, 4, 5, 3. Now we're doing 4, 2, 5, 1, 3. So the way you can visualize this, like I said before, you can kind of imagine there is some sort of line curve here starting on the left-hand side. And for the in order, what you're going to do is you're going to print or process the node. If this curve, it kind of goes below, right under the node. So I'm going to start kind of tracing. So far, nobody is below. So far, the curve is not below any node, right? And finally, I hit this. Hey, I'm below 4. See that? I'm below 4. Therefore, I print 4. And I keep going again around the tree. Oh, I'm below 2. See, I'm below 2. Print 2. Keep going, keep going, keep going. I'm below 5. Print 5. Keep going, keep going, keep going. I'm below 1 now. If you look at here, below 1, print. Keep going around. I'm below 3. Print 3 and all the way around, all the way to the back to the root. And that's how you visualize Inorder traversal. Now let's get to the exercise. I'm going to do the HackerRank exercise 3 Postorder Traversal. I'm going to use Java 8. So we're given the function Postorder. I'm going to use a recursive solution. So the way we do this is when we have Inorder, first we got to traverse its left child, and after that we process the current node, and then we do the traversal of the right child. So the name of the function is Postorder, so I'm going to do that. But before I do that, there's a base case that we got to do. So the base case, if the root is null, that's when we stop. We can just return, hey, I don't have to do anything else. Otherwise, keep going. There is something to process. So first going to traverse or call Postorder on the root.left first, if there is one. So if root.left is not null. And only after that is when we do the processing of the present node, the current node, which is root. So we just, in this case, you just want to print it out with a space between the numbers here. That in that case, I'll do system.out.print. We're gonna do root.data plus concatenate with a space to its right-hand side. And then finally, after processing, we can finally do its right-hand child. If root.right is not null, that is something to process on. There's a right child. Postorder with root.right. So gonna recursively call that. And that is it. You see, the only difference between this and Inorder is that the print is before for preorder, and for Inorder is in between. And then later you're gonna see that for postorder, it's gonna be afterwards. So that's the only difference. And all of these are part of DFS, adapt first search. So okay, what did I do wrong here? Oh, this is postorder. I meant to do Inorder. So let me copy this to Inorder. I meant to do Inorder, so this should be called Inorder. There you go. We got 1, 2, 3, 4, 5, 6. And if you draw the line here, as you draw the curves around the tree, as you come below a node, you're going to print it. Nothing below, nothing below, nothing below, nothing below. Hey, we got 1 there. You got to make it like this, I suppose. So below 1, below 2, below 3, below 4, print. Then below 5, below 6, nothing there, all the way up. Well, they made the numbers here very convenient to be in order. It would be nice to be out of order to better visualize. But anyway, that's it. Now let's do the post order. Let me explain. Okay, now let's do post order, the one that I had mistakenly done. Let's draw a geometry. 1, 2, 3, 4, 5. So I drew a tree. There's a node. A root node is a node with a value 1. It has a left child of value 2, a right child node with value 3. And then for the left child, which is the node with value 2, it has a left child of whose node has value 4. It has a right child whose node has value 5. Now, how do we do post order? Post order would be you traverse the left child, you traverse the right child, and finally you can finally process the present node or current node. That's different from when you do pre-order. Pre-order, you first do the processing, which is before you traverse left and right. For Inorder, we do the traverse left, then process the current node, and then traverse right. In this case, for post order, we do the traverse left, traverse right, and then finally process itself. So that would be like if we call traverse the function with some current node, which is initially the root, and have some pseudocode here. The base case would be when there's nothing, but the current node is just no, is no. We don't do anything, just return, so nothing to do. Otherwise, and we're gonna do traverse the left child, which I just call L, current the left, traverse the right hand child, which is current that right, I just call it right. But provided that if there is one, it's not null, right? Provided that there is one for the right, it's not null. Finally, I do the processing. That could be printing it out in our case of the current node. You can say whatever data if you want there. And visually, that's like as you reach the node from the right, you print them out. Let me do the curve here. I'm drawing curve. I'm drawing a curve. I reach 4 from the right. I reach 5 from the right. I reach 2 from the right. I reach 3 from the right. I reach 1 from the right hand side. So this is what it should look like. Let's see if it's actually doing that. If I follow the code. I follow the code here. So let's traverse with the root. It's 1. It's not null. So we're going to traverse left. Okay, do 2. Recursive call, go back to the top. It's not null. We're going to traverse left again, 4. Go back to the top. It's not null. Traverse left again, which is no. There's nothing there. So return, go back. Then traverse right, nothing. Return. Then finally return back. Finally do the processing, right? 4. And then go back to 2. And we're going to do traverse right. And I'm going to traverse, go back to the top, not no, traverse left, nothing to do, traverse right, nothing to do, finally process, which is print. Go back to 2, finally, done, process 2. And go back to the node with value 1. We're going to do traverse right, then go back to the top, recursive call, not no, traverse left, nothing to do, traverse right, nothing to do, right? Nothing to do there. And then we're going to finally go back and to the third and print it, and finally go back to the recursive call 1, and I can finally print it out. So it matched. My algorithm matched what I saw visually. So now let's get back to the problem that we had. So I'd actually done it by accident. I meant to do in order, but I actually did it here. But in any case, let's do it again. So post order, base case would be if the node, the root or the current node is null, we have nothing else to do. We're going to just return. Otherwise, when you're doing post order, remember, traverse, recursive traverse the node's left child first, and then recursively traverse the node's right child. And only after that is when you process. In our case, we just print it out. So if there is a root dot left, that is not null. I'm using Java 8, by the way. We're gonna do the recursive call. The name of the function is postorder with root.left. After that, if there is a root.right that is not null, gonna recursively call postorder itself with root.right. And finally, when we do traverse left, traverse right is when we're gonna do the processing of the present or current node, in this case called root. And we're just going to do a print out because they want us to print it out with a space between the value, the integers. We're going to do system.out.print of root.data. I'm going to concatenate to add a space there, and that's it. It's a void return type, nothing else to do. Okay, so if I visually match, let's just check visually if that's correct. As I trace the curve from the left-hand side from the root all the way to the bottom and then going back and surrounding it all the way back to the top, as I looked at the nodes from the right-hand side is when I print them out. So if I touch a node from right-hand side, I print them out. So I'm going down there. I'm going down, 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 down. Hey, I'm reaching 4 from the right-hand side. I'm gonna print. Hey, I'm reaching a 3 from the right-hand side. I'm gonna print because this is post order. Okay, bottom from 5, 6 from the right-hand side here. We're gonna print the 6. 5 from the right-hand side here. We're gonna print the 5. 2 from the right-hand side. We're gonna print the 2, and then finally go back all the way to the root. I reach from the right-hand side. I'm gonna print the 1. So that's how we visualize that order, post order. And that is it. I think we're done with questions for the day. If you do have a question, please let me know in the chat. Don't forget to follow. Follow me. If you like this lecture, consider donating, giving us a tip. Here are my QR codes. Please help us out. You got Cash App, PayPal. We got Bitcoin, got Venmo, got Zelle, whatever you need. Just scan the QR code. Please consider making a donation, leaving a tip, so that we can still continue doing this. Thank you for the support. I hope that you like this lecture today. Here are the QR codes. I'd appreciate it if you could leave a tip. Scan the QR code of your camera app. It will redirect you to the corresponding application like Cash App or Venmo or PayPal. And then you can leave a donation or a tip. You can help me with my efforts with this session. Thank you so much. See you next time.